Can't wait to see what we got. So girls, can you tell me what you got when you plugged in 5 into the first expression? 8. Anyone get something other than 8 for the girls? All right, boys, what did you get when you plugged in 5 into your expression? 32. Any other answers out there? Oh, I got 8. Okay, 8. 8 also. Someone returning my work, that's perfectly fine. I'll even give you a tip for how to get the answer every time. Like at least with Desmos. But yeah, so let's just kind of see what we've got. We'll see which one's actually right in a second. Girls, what'd you get for when you plugged in 7? Anything else? Boys, what'd you get when you plugged in 7? 21. 20. Girls, what'd you get when you plugged in -1? Any other answers for the girls? All right. And then for the boys, what'd you get when you plugged in -1? -4. Okay. And then girls, what'd you get when you plugged in 13? Okay, what I hear? Okay, boys, what'd you get when you plugged in 13? 80. Okay, so are we noticing a trend? The girls and boys. So, I mean, of course, there's some like other answers too. But what you should have seen is that all the answers were the same for each expression, whether you had the first expression or the second one. Now, we should probably talk about how to get it right, no matter what. And I know when I was walking around earlier, I saw some people using like their phone calculator, not even like Desmos on their phone, just like the one that's an app on your phone. Those are horrible. Okay, try not to use those. Because if you're using those, then you really have to know your order of operations. So like that you have to do parentheses first, then exponents, multiplying, dividing from left to right, adding, subtracting from left to right. What you could do instead, and even on state testing, you'll have a calculator that can do order of operations, just saying. You just have to know how to use the calculator. But Desmos you get on all your other tests. So I'll show you on that one. All right, so if I'm typing in the girls' expression, theirs is in like fraction form. So I'm gonna put up the keyboard, I'm gonna press the division symbol so that I get the fraction bar. And then anywhere that you have to plug in a number, use parentheses. So if I'm plugging in 5 to the girls' expression, that is why it's 8. Okay, and then what makes it really easy, especially since I use parentheses, now each time I just have to change the number. So then if we plugged in 7 for the n, and so forth. All right, I'll change it back to the 5 for now though. And then for the boys, you guys started with parentheses. So even though it might not make a difference, still use parentheses anytime you plug stuff in. And then we have another fraction bar. So I'm making it look exactly how it looks on my paper, but plugging in the numbers for the n. And you should probably practice this too as I'm doing it. But anyway, that's what we got for the boys too. That's why for the boys, you should have gotten 8 as well. And then again, do it for the 7, the -1, the 13. The -1 had the most like random answers. So let's look at that. This is why it's so important to use parentheses every time you plug stuff in. And remember, boys, you had 2 places to plug in, so make sure you change both of those 2 places. But look what happens if I took away the parentheses in the girl's expression. So the answer is -4, but if I take away the parentheses, it says the answer is -5 when it's really not. So the calculator is smart, but only as smart as like how you enter it. Because if you don't put the parentheses, it reads it as 1 squared and then times the negative. When really it's -1 squared. So -1 times -1 should give you a positive. All right, questions on that warm-up? All right, so it's good practice, like practicing plugging stuff in, learning how to use the calculator. But the main point of the warm-up is actually why these have the same solution. So why do you think, even though these are written differently, that they gave me the same solution? Do you think it'll work for any value of n that I put up there? Yeah. And you can even test it out now that you have it up in Desmos. But it'll work for any value of n. So what does that mean about the two given expressions? Why can they look so different but give us the same answer? Because they are equivalent. Good. And if you look at the title of today's lesson, that's what today's lesson is. Equivalent equations. All right, questions on that? Okay. So these two, even though they look so different, are equivalent because no matter what I plug in for n, I will get the same answer for both, as you can see here. All right, now moving on. We have this activity. So follow the titles that are up here. We're looking at the part that says much ado about ages. So you are going to write as many equations as possible that could represent the relationship between the ages of two children in each family described. If you use a variable, just make sure you can tell me what your variable represents. So in family A, the youngest child is 7 years younger than the oldest, who is 18. In family B, the middle child is 5 years older than the youngest child. So you're writing as many equations as possible to represent each. What do equations have to have? So make sure each thing you write down has an equation. I'll give you 1 minute by yourself, so no talking for 1 minute. I'll let you know when to share with your group. For family A, or one of the equations. Did I hear you right? 180 minus 7 equals y? Oh, okay. I heard a 1. So 18 minus 7 equals y? Yes. And then the y is what? So the age of the youngest. All right, class, does that one make sense? Yes. Okay, table 5, give me another one you guys have that's different.
7 plus y is 18.
7 plus y equals 18. Does that one also make sense? Yes. And how do you know it makes sense? It's the opposite, it still works. Any volunteers now? Any variations of these? Because I know I had like at least 6 in my answer key. Justina? What minus 7 equals y? Okay. I want to make this look more like an O. So maybe like let's get it different. Okay. G for oldest. I mean, you could use O, but like it just looks too much like a 0. All right. I don't see a problem with that one. Any other equations that we could have had, Josie? Okay, good, so just this one, but y equals on the other side, that works. Others? All right, then let me see what wasn't said. Or maybe that no one cares to share. Okay, so one that I had is 18 minus 7 equals 11. So you didn't have to use a variable, but you could have. Not, you just needed to have an equal sign. Then we had 11 plus 7 equals 18. 18 minus 11 equals 7. So let me add that one up there because that's more different than the ones that are around. So 18 minus 11 equals 7. And 18 minus 7 equals A, which you guys use Y, that's fine. A plus 7 equals 18. I'll put Y. And then 18 minus Y equals 7. So all of those give me what as an answer for the variable if you use one? 11, that's the age of the youngest. There was enough information that you could have figured it out, and so forth. Now for family V, table 1, can you tell me what you had? Y equals n minus 5. Y being which one? The youngest. The youngest age. Okay, good. Now let me see if I can reason that one in my head. So the middle child is 5 years older than the youngest child. So the way that I probably would have started, since it's 5 years more than or 5 years older than the youngest, I might have started with 5 plus Y to give me the middle child's age. Now to see if that one's right, because it's easier for me to start with this and then rearrange this to see if that can also be true. So in the one that Riley gave me, the Y is alone. So this one I know is right because I just reasoned it myself. If I want to get the Y alone, how would I cancel out that 5 that's next to it? I would subtract it. And it's a rule that whatever you do on one side of the equal sign, and then that does give me what Riley said, so that works. So add it to your list if you didn't have that one. So if you can rearrange it to become the other one, then that also works. As long as you're not like breaking in math rules. You're allowed to do something to either side as long as you do it to both sides. So there's that one, mine also works. And then aside from doing like Y plus 5 equals M or something like that, what other ones do we have out there? There's at least one. We have where the Y is alone, where the M is alone. Is there a way you can get the 5 alone? Maybe? Y minus M equals M. Okay, M minus Y works. Could Y minus M work? No. The reason why I know Y or M minus Y works is because look, over here, if I want to get the 5 alone, how do I get rid of the Y? I'm gonna leave it on one side. So then now I have M minus Y and now the 5 is below. So I know that that works. All right, the reverse would not be true because then the 5 would need to be negative and all that stuff. All right, anyway, these main three and then maybe some slight variations like. I don't know, y plus 5 or -5 plus m, like that also works. All right, but good. Now make sure you have at least these three. I mean, you should have been taking notes as we went all along. But make sure you have these three for family B, because I'm gonna switch it and ask you a different question about it. Right, so for family B, we need to make sure we have these three box ones. Now. Tyler thinks that the relationship between the ages of the children in family B can be described with 2m minus 2y equals 10. Where m is the age of the middle child, y is the age of the youngest. And what you guys need to do is explain why Tyler is right. So if this was a constructed response, don't tell me that Tyler's actually wrong. We're saying that that is also an equivalent equation. Compare it to the ones that we wrote down for family B. Why is Tyler right? So think about it yourself and then talk with your groups, no more than like a minute or two. Are you able to tell me why Tyler is right? Okay, tell me what you think. So 2m is like middle child is, and then 2 Okay. Anyone else have anything? All right, anyone in the class think that they know? Jude?
Middle child is 16, and you times that by 2. So that's and 2 go together, 16 times 2 is 32, and then the youngest child is 11, you times that by 2 to get 11, so it's 32 minus 22.
Okay, so you're plugging in numbers and it's working, okay? That could be one way. Christina? Okay, good. So while you could like pick numbers and see if it works for both equations, like Jude said, this is more like what Justina said is more like how I thought of it, that I thought was easy. It really looks like they just took this equation, which is really similar to this one. It's also m minus y. And they just multiplied the entire thing by 2. And you're allowed to do that. Because it's a rule that whatever you do on one side of the equal sign, you do to the other side. So I have to do it, and when I do it to both sides, I get 2m minus 2y equals 10. So that's another way how you can tell, because they could look wildly different. But if you can manipulate one of the equations, and you can manipulate it all sorts of things, adding on each side, multiplying on each side, whatever. As long as you're not breaking any math rules, if you can manipulate it to become the other equation, then they are for sure equivalent. All right, so that kind of brings me to this sheet. So you might have noticed you picked up 2 papers on your way in. Look at this one now for a bit. Because what we've been talking about, and while we've not been like explicitly saying the names of the properties, what we've been talking about are properties that you might get asked about on a test, hint, and then like on your state testing as well. They love to put problems like this up there where, and I'm more so talking about like the one below down here. But they love to put problems like this up here where they say, find the mistake, or tell me if there's a mistake or not, or tell me if they labeled the properties wrong and what property it should be. All right, love to put those on tests. So in that case, you should probably kind of at least familiarize yourselves with them. And let's start at the top of the page. So some basic number properties, which you might already understand these rules, but here's the actual names for them. So we have the commutative property of addition and of multiplication. And what that basically says is that the order doesn't matter. That you add or that you multiply. So like if I'm giving some examples, so I'll probably write this down. 3 plus 2 is the same as 2 plus 3, is it not? It is. And then for multiplying, 7 times 2 is the same as 2 times 7, right? So when order doesn't matter, it only applies to addition and multiplication, then that's your commutative property. One thing I really hate is that they put X's here for multiplying. Don't do that anymore, at least. Because we use X's for variables too. Do the dots or parentheses for multiplication, but if the order doesn't matter, then it's the commutative property. Then we have the associative property. That one has to have parentheses in it. And that basically says that if I group things differently in an addition problem like this, I grouped A and B, and then I grouped B and C, it doesn't matter, I'll still get the same answer. And then the same works for multiplying. If it's all just multiplication, but I decide to group the first two or the second two, my final answer will still be the same. So I won't put examples for both of these, so let's do the addition of each. Say I have 1 plus 2 plus 3. 1 plus 2 plus 3. And the only thing that's different is where the addition symbols are. So maybe the first time I have it around the first two numbers, and the second time I have it around the second two numbers. Because it's addition, it doesn't make a difference. And then you can do the same thing with multiplication, make those all multiplication signs, and there's another. Questions on that? So then identity properties, there's one for addition and for multiplication. And these are probably things you already know, but the property is the identity. And that says that if I add 0 to any number, what do I get? Not 0. I get that same number. So give me a number. If I do 7 plus 0, what do I get? Easy. Same, well, similarly, for multiplication, there's also an identity property, and that's timesing anything by 1, what do you get? Whatever you multiply by. So give me a number. Okay, I heard 8 first. So if I do 8 times 1, what do I get? Okay. So now just know the name that goes with it. Identity property. All right, this one right here is major. It's in a lot of problems. Usually something that you have to check for first. And that's if you can distribute. Because if you can, then you need to do that first. So distributing, can someone just explain that to me? All right, so distributive property. What does that one say? Sorry, what was that, Riley? Take it apart and do it separately. Can someone elaborate on that? Because I wouldn't say it's not necessarily. I wouldn't say take it apart and do it separately. What would I actually do? What math am I doing for the distributive property? What am I multiplying? Okay, good. So you know you need to distribute when it's in a format like this or like this, because you could also have it be subtraction. But what you would do is you would take that outside number and multiply it by both the inside numbers. And then what you get is A times B plus A times B. Same thing down here, except for A times B minus A times C. Questions on that? Okay, I won't show you an example of that. I feel like that's just the way to do it, right? You'll see in your. Feel free to create your own if you want. Anyway. Now here's a few other major ones. So addition property of equality, subtraction property of equality, multiplication, division, property of equality. These are the ones that we talk about a lot, but like we don't usually attach the names to it, but they will on your test. So what this one basically says, and like we kind of observed already, is that you can do anything to an equation as long as what? As long as what? You can do anything to an equation as long as you do it to both sides to keep it equal. So that's basically what the properties of equality are saying. So if I'm adding on each side, that's my addition property of equality. If I'm subtracting on each side of the equal sign, that's what that's called. The subtraction property of equality. If I'm multiplying on each side, the same thing. That's my multiplication property of equality. And then if I'm dividing the same thing on each side, that's my division property of equality. Questions on that? All right. So let me show you an example of something you could see on a test. I think most of the time, we don't have this middle portion, like the actual where they're doing the math. Normally, you would have to know what math they're doing to go from the step 1 to the step 2. So like, what did they do to go from here to here? They distribute it. So that's the only way that like the parentheses would go away and we get 4, that's 4 times 1, plus 24x, so the 4 times 6x. The right side didn't change at all. It usually doesn't when you just distribute it. But that's my distributive property. Then you have to see what was done to go from the second step to the third step. So what did I do to make that 4 go away? And whatever you do on one side of the equal sign. So that would cancel out the 4s. That's why the 24x is now alone. And that's why 52 went down by 4. You get 48. But the property that you just did is what? Good. And then see what we're doing to go from step 3 to step 4. By good. That's how the x goes away, because then you get 1 times x, which is x. 48 divided by 24 is 2, but what we did is and that's basically what your test would be like. I just helped you answer like a few questions on your test. You have to know how to do the math, and then what property goes with it. Questions on that? So then on the back of this paper, there is one at the bottom that's similar. It starts with like 4 parentheses 3x minus 2. Try that one. I wouldn't worry so much about writing the math in the middle part. If you do it like how I did, that's fine. But what's really important is knowing what the math was to get there and then what property goes with it. So do the problem on the back of that. I'm going to switch to it now. All right, you tried this one. I'll give you like 2 minutes. If you finish early, you can compare with your group. But try it yourself first. So what math do we need to do to go from the first row to the second row? Good, we need to distribute. And the way that they are writing this, normally I put this over here and then first I put like just given, but I'll follow the order that they do. It's the distributed property that they did first. Big indicator is the parentheses went away. And then 4 times 3x is 12x, 4 times -2 is -8. Then what did they do to get from the second row to the third row? All right. Addition, property, and don't just stop there because there's lots of addition properties. It's the property of equality. And yes, that is true, because the way that they made the -8 go away is by doing what? By adding 8 on both sides. So notice 40 also went up by 8. That's even it. Then how did we go from the third row to the last row? Okay, good. They divided 12 on each side, so when they divided on each side, that's not the division property of equality. And then that gives me my final answer, because now x is alone, so that's my 2. Questions on that? All right, thanks for keeping up, going on like both note sheets, we're almost done. We'll go back to the original note sheet. Look at number 2 that's printed on your note sheet. It says, which, if any of these are equivalent, and then how do you know? So work on that one. I see some people writing still, so I'll stay on the screen for a little bit. We'll go to your other note sheet, look at number 2. Which, if any of those are equivalent, and how do you know? Which do we think are equivalent? I'll take a volunteer. Are any of them equivalent to the first one? Riley? Okay, you think they're all equivalent. Why? So did you solve each of these? Or did you just like pick a random number and? Okay, you isolated the variable in each of these. So if you're starting with the first one, what would you have to get rid of first? And how do you get rid of it? On one side. And then I have 3a equals what's 15 minus 6. And then take a look at what happens. This is now this. 3a equals 9, 3a equals 9 here. However, if we keep doing the math, you'll see for the other ones, maybe what's the opposite of multiplying by 3? And then we get that a equals 3. And then this is literally the exact same at that point. So a will also be 3 here. If we isolate the a over here, how do I get rid of the 2? Subtract it on each side, I get a equals 3 again. And then this one's a little bit more challenging. However, there's a few ways you could have solved it. If you were like, okay, I need to divide by 1/3, that's fine. You could have. And then whatever you do on one side. And if you hate fractions, I understand a lot of freshmen do, but at this point, like you do get to use a calculator. You just have to know how to use the calculator. Like you could use Desmos, for example, to do your problems with fractions. So if I want to do 1 divided by 1/3, my only suggestion would be make sure that you put any fractions in parentheses so that the calculator can read it right. So you could have done 1 divided by 1/3 and got that a equals 3. you could have figured out that to cancel out a fraction, you multiply by the reciprocal, so you could have multiplied 3 on each side, because that would be the reciprocal of 1/3. And then a also equals 3 when you do that. But yeah, since you could isolate the variable in all of them and get the same answer, that is a reason why they're all equivalent. Now, let me show you one more before I send you on your way to do your practice. This will help you. Another thing you could do to prove that they're equivalent, so we saw by rearranging them, by solving them all, and if they have the same answer, you could also put them in Desmos, and if they give you the same graph, then they're also equivalent. The only thing is that Desmos doesn't read A's. What does it read? X's and Y's. So I'm going to replace this for an X because usually that's our input. And then if I type in all of them, so everyone look at the screen for a second, this will make your life easier. But I have, for the other equations, 3x equals 9. Look, it's on the same line. X plus 2 equals 5. Also on the same line. And 1/3 a or x equals 1. They are all on top of each other. So they are all equivalent. That could save you some time on a test. I wouldn't use Desmos as a starting place. I would use it to check my answers. But like that's a good way to save time on a test and make sure that you're doing it right. So any questions on the lesson? Okay, you still have like 2 solid minutes before you need to pack up. So highly recommend get at least like a problem knocked out on your practice. Make sure you do your work always. If you don't do it during class, then it just cuts into your own personal time. So yes.